Alright, so we're going to try this system of equation problem. We have y equals x plus 4 and y equals negative x plus 6. These are both in slope-intercept form, so we could graph them. But we've been practicing substitution method. You can still do that here. If you understand the idea that y equals y, but y is also x plus 4, and y is also negative x plus 6, and we can understand that x plus 4, which is another way to say y, is equal to negative x plus 6, which is another way to say y. Okay? Now we've created a one-variable equation. On my line. Now I have variables on both sides. Remember we talked about this earlier in the year. There's 4 different ways you could write this. You even could have had negative x plus 6 on the left side and x plus 4 on the right side. So again, multiple ways to do this. But let's try to combine the variable expressions first and try to keep them positive. So I'm going to add x to each side. This cancels out. I get 2x plus 4 equals 6. It's okay if you didn't start this way. You can still get the right answer if you do the math process right. I'm going to subtract 4, using inverse operations. I get 2x equals 2. I divide by 2, and x should equal 1. Again, this is part 1. The second thing, once I know x is equal to 1, again, it's x comma y. I know my answer is going to be some form of coordinate, at least for now. I have 1 comma something because x is 1. So for part 2, I'm going to take one of the 2 equations. It doesn't matter which one. And substitute 1 in for x and solve. So y equals x plus 4. Y equals 1 plus 4. So y must be 5. So my answer should be 1 comma 5. Well, lastly, we have to, of course, check. To check, it does matter which equation we use. Because I use y equals x plus 4, the top equation for part 2 to solve for y, I'm going to use y equals negative x plus 6, the bottom equation, to do my check. I'm going to substitute 5 in for y, 1 in for x, and I'm going to solve. Negative 1 plus 6 is 5. And 5 equals 5. Therefore, my answer of 1 comma 5